Dear all, welcome back to LeetCode 144 binary tree pre-order traversal problem. So first, let's study the question what it tells. Given the root of a binary tree, return the pre-order traversal. So here it tells that we have to return the pre-order traversal and input. So this type of input that will be provided in the question, and that is the output. That means we have to return that one. So whatever the root, this input, whatever the input is provided here, we have to construct it and pass it through the our main function. So the things that is the root input, we have to pass this input in our main function. So that is the core goal. So for that, these inputs will be passed through the main method. Main method. Okay. Now, given the root of a binary tree, return the pre-order traversal. So what is pre-order traversal? Pre-order traversal is first where we first visit the root. The orientation will be like this. First, we'll be visiting the root, then we'll be visiting the left side, and then we'll be visiting the right side. This is the orientation of pre-order traversal. So how we can construct, what should be the approach? First approach should be, first we have to declare the main method. That means first we have to construct this tree in the main method. After that, we have to proceed through this method, the pre-order traversal. Then we have to construct the main method. So I will make you understand one by one. First, let's construct the tree, and this tree is called the root. This is called the root, and for that we have to declare the variable root. So let's start in the question. Okay, so right now we are in the main question, as you can see. So this is the tree node that we always use. That is the tree node that we always use in any question. But in LeetCode, it's already provided in their manner. So now we have to create this one. You can see we have to create a node of the class type tree node. This class type. So let's create tree node root. Tree node root. So now we have created a tree node. Now our first task is to construct this tree, the input. So we have to construct the input. So let's public static so okay, I just created the object of main class. We have to declare the main method. So once we have declared the main method, now we will initialize the first one. This is the root node. So let's initialize this. So how we can access this root? We have to access through the object of this class. So object is solution1. Solution1 dot root. That is equals to, now we have to create the tree node, new tree node. And what is the value? That is 1. Okay. Now in the left of this, no, now we see the, observe the 2 is in the right of 1, 2 is, this 2 is in the right of 1. So in the right there is 2. So now we'll be initializing the right. Solution1 dot root dot right, new tree node. Okay, now 2. Now we have constructed the 2, and now if you just observe, first we have just build the 1, then in the right we build the 2, and if you just notice in the right, after this right, in the left section there is 3. So now we have to initialize this 3. So let's write this 3 also. Okay, so now in the right section, solution1 dot root dot right. So from root we are moving towards the right, and from right towards left. So dot left, new tree node, and this is 3. Okay, now we have created the tree. So what it tells, that we have to return the output. The output should be 1 2 3. That means this is the output of this method. So that is the output. So we'll be getting the output in this fashion. So let's copy it, because that is the return type, and that will be the result, and result will come from this function. So object solution1 dot tree, and now we have to pass the root. So solution1 dot root. Okay, now this method is done. We have already created the root. Now our second task, first we have initialized the root first. Now our second task is to initialize this method. That means how we have to now implement the program for how our tree. Let's tell this is the tree 1 2 3. So how our program will actually traverse the tree, for that we have to write the program. So how we can write the program? in case of binary tree pre-order traversal, first we have to visit the root. So if we just apply recursion, it will simply work. So how we can apply the recursion? Just notice the type here. This return type is list of integer. That means we cannot use binary tree traversal, because when we apply the binary tree pre-order traversal, there is void. So we have to use an external function, and for that we'll be using our external function pre-order helper class. Let's call this class 123, and now we'll be using pre-order external. So let's take it to the back for understanding purpose. Okay, so now we'll be visiting towards the pre-order class. Pre-order pre-order helper, and now we'll be creating a pre-order helper. So first, from this function we have to pass something that it returns something to that. So we always have to return this list of integer here. I mean, we have to return this. So we have to construct the result of this function in our helper function. So we'll be constructing that one. So we'll be taking the binary tree node. So tree node root, tree node, let's call it node, and we'll be taking the result, that is the list of the integer result. Okay, now after this we'll be writing the function. So while we traverse, we can get two cases, that there is empty node and there is completely tree node. So first we'll be handling the empty or null case when we get the null. So first we'll be checking if the node is equals to null. If node is equals to null. So if node, notice this is a node, this is called a node. So if node that is equals to null, so no need to check anything, so we'll be just returning the program. So return. Second case, if the node is not null. So if node not equals to null, node not equals to null, then we have to keep traversing from here to here. So all those traverse will happen if the node is not equals to null. So this is pre-order. That means first we have to process the root. So first we will be adding the root. So this is the root. So result.add result.add 1. Now we have added the root. After we process the root, we have to work with the left portion, and then we have to work with the right portion. So now we have to visit the left one by one. We have to keep visiting this left one in recursion fashion. So let's apply the recursion function. Pre-order helper, pre-order helper, and now this node. So we will be passing the node. This is in node dot left, because we want it in the recursion manner, and then we'll be initializing in the function pre-order helper node dot right. So this tree will automatically work, and it will completely return, it will completely fill the result section, the result it came. So now we'll be here we'll be just initializing the result. So in this function we'll be initializing just the result. So we'll be writing the result like this: list of integer result, and the result can be of any type, array list or linked list, new array list. And now we'll be calling the function that we created here. So we'll be calling it from this section, pre-order helper. Okay, and we'll be passing the node. That means we'll be passing root from here, this root, and we'll be passing this result. So result, and this result will get entirely filled from this function. And once we get the result from that function, we'll be returning this function. This function will fill this result, and at the end we'll be returning return result. So okay, I hope you understood from here. Let's code it in LeetCode. Okay, so now we'll be constructing the result array, list integer. Okay, now array list has been constructed, and now we'll be adding we have to create that function. So we have to return the return result. But now result is not filled. So for that we'll be using the helper function preorder helper, and from here we'll be passing the root and the result array to fill. Private void preorder helper, and root is of type tree node root, and the result list of integer result. Okay, now we'll be checking the base case. If root equals to null, so if the root is null, we'll be returning return. Now the second case, if root is not null. If root is not null, then first we'll be processing the root node result dot add root dot val. Then we'll be processing the left side. So preorder helper root dot left, and it will entirely process all the left side, and we have to also pass the result array. So okay, and then we'll be processing preorder helper root dot right comma result. Okay, so if we just run this program, it will work. Okay, it just worked. So we'll be meeting in the next video session.